All right, we're going to finish up the 3-6 notes. This says, write a quadratic function p with rational coefficients such that p of x equals 0 has 2 plus 5i as a root. All right, so what we're going to do is we're going to start with x equals 2 plus 5i. And now, if you remember, we have to have the conjugate, right? So all complex and irrational functions, zeros, complex zeros, irrational zeros have to have the conjugate. So the conjugate, really, we just switch that middle sign, so x equals 2 minus 5i. All right, so these are the zeros. What are the factors? So if we can get this set equal to 0, we'll have our factors. So x minus 2 minus 5i equals 0. That's our first factor. Here we're going to subtract 2 plus 5i to both sides. So x minus 2 plus 5i is going to equal 0. And these are my factors. So the function is p, so we get p of x equals the first factor, x minus 2 minus 5i, and our second factor, x minus 2 plus 5i. Now, we can speed run this. All right, we have conjugates, so a minus b and a plus b turns out to be a squared minus b squared. All right, did you notice that? X minus 2, I'm going to say, is one thing, and then 5i is my second thing. And this comes back to our difference of perfect squares. All right, x minus 2 squared turns into x squared minus 4x plus 4. And 5i squared is going to be a minus 25i squared. Now recall, I squared is negative 1. So we get x squared minus 4x, a plus 4, and then we have negative 25 times negative 1 is a positive 25. So 25 plus 4 is a grand total of 29. That is our polynomial equation with the zeros of 2 plus 5i and 2 minus 5i. All right, moving along here, this next problem, this says polynomial function q of degree 4. All right, so that we have the roots 3 minus root 7 and 4i. So we get x equals 3 minus root 7. We need the conjugate, so x equals 3 plus root 7. 4i, so x equals 4i. And the conjugate, now there's no middle term, right? So this really says 0 plus 4i. So we'd have to switch the middle here. So x equals a negative 4i. All right, get this all set equal to 0, so we're going to subtract 3 and add root 7, so x minus 3 plus root 7 equals 0. That's a terrible one. I could do better. Equals 0, and then here we're going to subtract 3 and subtract root 7, so we get x minus 3 minus root 7 equals 0. Over here we're going to subtract 4i, so x minus 4i equals 0, and here we would add 4i, so x plus 4i equals 0. All right, so q, we have the polynomial function, q of x equals, and in factored form we have x minus 3 plus root 7, we have x minus 3 minus root 7, and we have x minus 4i and x plus 4i. Whew! All right, so obviously I'm going to do, it's not obvious actually, I'm going to do my conjugate pairs first. All right, so here we're going to get x minus 3 squared minus the square root of 7 squared. All right, all of that times x squared minus 4i squared. All right, so here we end up with x squared minus 6x plus 9 minus, now the square root of 7 squared is 7. Over here we end up with x squared minus 16i squared. Hold on, we're almost there. Cleaning this guy up, we get x squared minus 6x plus 2. Over here, that I squared is negative 1, so here we get x squared plus 16. And now we have a trinomial times a binomial, 6 total terms here. So we get x to the 4th plus 16x squared minus 6x cubed. Nobody knows what 16 times 6 is. Good gravy. Come on, we can do this. We can do hard things. So let's see, 6 times 16, 96. Oh, good guess. Whatever was that? Okay, so that's minus 96x, and now the 2, so plus 2x squared plus 32. All right, to clean all this up, I got to use my space down here. So q of x is, so x to the 4th, that's my degree. It's the 4th degree, yay. Minus 6x cubed, okay. 16 plus 2 is a grand total of 18x squareds minus 96x's, all that plus 32. There's my polynomial. Not bad, not bad at all. All right, again, if I go too fast through any of this, please pause and write it down. Try this out on your own. Try it out on your own. See if you can get it. All right, so quadratic function, quadratic, that means the degree here is 2. So x equals 5 plus 4i, and x equals 5 minus 4i. All right, so subtract that. We're going to get p of x equals x minus 5 minus 4i times x minus 5 plus 4i. Yeah, I'm going quick. Now I can speed run this, right? X minus 5 and 4i. So we get x minus 5 squared minus 4i squared. So x squared minus 10x plus 25 minus 16i squared. So that's really saying I squared is negative 1. So all of this tells me that p of x is x squared minus 10x. 16 plus 25, that's a positive 41, dog. All right. Degree 4. Oh, man. 2 minus root 3 and 5i. All right. We'll try and do this in this very little space, so wish us luck. So, we have q of x equals, now I'm just going to hop right to the factors. You know how to get the factors. Set them equal to 0 and then solve to get 0 by itself on the right side. So here we would get x minus 2 plus root 3, x minus 2 minus root 3, x minus 5i, and x plus 5i. All right, so I have my a and my b here. We get x minus 2 squared minus root 3 squared over here. So that's our first one. It's going to get multiplied with this guy. So here we would have x squared minus 5i squared. All right, so expand this whole thing out and get them together. We get x squared minus 4x plus 4 minus the square root of 3 squared is 3. That guy. Times this guy here, we would get x squared. So 25i squared is a positive 25. So that 4 minus 3 is just a 1. So if you don't mind, I'm going to do this. Plus 1. And then x squared plus 25 is my other polynomial there. So x squared plus 25. All right, so multiply them all the way out. We get x to the 4th minus 4x cubed. Oh, no. I'm not going to do that. X squared here is x squared. This is a positive 25x squared. Negative 4x times x squared is a negative 4x cubed. Negative 4x and 25 is a negative 100x. Wow. And then 1, so that's a plus x squared plus 25. And cleaning this up, q of x equals x to the 4th minus 4x cubed. 25 and 1 is a positive 26x squared minus 100x plus 25. Okie dokie, Smokey. Now, these guys here, I'm going to do on a separate piece of paper, assuming that I can find a separate piece of paper. Shoot. Oh, biscuits. Why don't I have paper up here? I don't want to do it on that. Hold on. I got you. I got it. Do hard things all the time. Okay. So, just so I have space, right? Problem number 5. All right, list all the rational roots. So that's the factors of the constant divided by factors of the leading coefficient. Well, my leading coefficient is just 1, so those are all the factors there. So I just need to list all the factors of 36. I'm just really quickly. 1 and 36. 2 and I believe 18. No. Is that right? 36 divided by 2 is 15. 3 is 18. Okay, I'll go with it. 18, just because it's fine. 3 and 12. 4 and 9. 5, no. 6 and 6. Alright, so all the possible rational roots. So we end up with plus or minus 36, comma, plus or minus 18, comma, plus or minus 12, comma, plus or minus 9, plus or minus 6, plus or minus 4, plus or minus 3, plus or minus 2, and plus or minus 1. That was gross. Right, because my leading coefficient is 1, all of these have a denominator of 1. Alright, whatever. Here we go, number 6. We can do it. We do hard things all the time. Again, the leading coefficient is 1. Factors of 12, 1 and 12, 2 and 6, 3 and 4. So we get x equals plus or minus, I guess I didn't do that here, x equals. Potential rational roots, we have plus or minus 12, plus or minus 6, plus or minus 4, plus or minus 3, plus or minus 2, and plus or minus 1. Those are all the possible rational roots. 7's where things get a little bit more interesting. So my P is factors are 2 and 1. My Q, the factors are 4, 2, and 1. Alright, so all the potential rational roots, x can equal. So I'm going to start with 1 and divide it by all these guys. So 1 over, plus or minus 1 over 1 is 1, comma, plus or minus 1 divided by 2, comma, plus or minus 1 divided by 4. Alright, now 2. 2 divided by 1, plus or minus 2 over 1 is 2. 2 divided by 2 is 1, I already have that, and 2 divided by 4 is 1/2, and I already have that. So that one was actually pretty friendly. Alright, number 8 says the P here is 16 and the Q is 9. So 16, 8, 4, 2, and 1, 9, 3, and 1. Alright, here we go. X can equal plus or minus 1 divided by 1, plus or minus 1 divided by 3, plus or minus 1 divided by 9. Alright, so we're done with the 1. Now we go to 2. Plus or minus 2 divided by 1, which is 2. Plus or minus 2 divided by 3. And plus or minus 2 divided by 9. Done with the 2. Sorry. We're going to keep going, comma. Now we go to 4. Plus or minus 4 divided by 1, which is just 4. Plus or minus 4 divided by 3. I don't have that yet. And 4 divided by 9, plus or minus 4 over 9. I'm done with the 4. Now we go to the 8. So plus or minus 8 divided by 1 is 8. 8 divided by 3 is 8 thirds. And plus or minus 8 divided by 9. Remember, each factor of the top divided by each factor of the bottom. Right? There's so many different possible combinations that we could have. Especially with a problem like this, right? 1, 2, 3, 4, 5 factors divided by 3 factors. It's going to be a bunch. Okie dokie. We are going to do these Friday in class. Good luck working on your homework. You can do great.